Okay. So now let me see what we did so far. We covered everything, and we are here in item number 6, in which this is not going to be a special product, and the leading coefficient will be 1. So here's where we are right here. Completely factor this type, a trinomial of this type, 1 x squared plus whatever x plus whatever. So we're going to start with m squared plus 13m plus 42. Now you remember this, but I will still review it quickly. We are trying to find two numbers whose product is 42, and I'll explain why this is the product. And this is the sum. Notice that it has to be taken with a sign in front. This is the sum. So I'm looking for two numbers whose product is 42 and whose sum is 13. Because the product is positive, both numbers have to have the same sign, either both positive or both negative. But since their sum is positive, I know for sure that both numbers have to be positive. So can we find two numbers, positive numbers, whose product is 42 and whose sum is 13? And the answer is 6 and 7. So that's why the factored form of this is m plus 6, m plus 7. Remember, you can rewrite it as m plus 7 times m plus 6. It's not going to make any difference. Good. Now let me explain why this is called, this number, descending order. That's a key. Why this number is called the product and why this number is the sum. Here's why. If I want to check my work here, I will do this. M times m, m squared. M times 7 plus 7m plus 6 times m, 6m plus 7 times 6 times 7, 42. That's why this is the product of the two numbers I'm looking for. And this number 13 is the sum of the two numbers I'm looking for. That's the reason why this is called the sum and this is called the product, because that's what they will end up being. They will be the product of the numbers that I determined, 6 and 7, and the sum of those two numbers that I determined. That's why they're called sum and product. Okay, so we can quickly move on to x squared minus 20, x squared minus 20 minus x. It's a trinomial, is in descending order. No, I have to rearrange it as x squared minus x minus 20. Greatest common factor, no. Negative leading coefficient, no. Special product, no. No special product has negative 20. It's not a perfect square. So then I'm asking myself, okay, if that's the case, then I'm looking for two numbers whose product is and whose sum is. The product must be, the sum is negative 1, and the product is always the last, yes. So negative 20. Since the product is a negative number, one has to be positive and one has to be negative. Since the sum is negative 1, the negative number is stronger than the positive number. Be very careful, because if you reverse them, that's not going to be the correct factor form. Yes? Yes. So negative 5 and positive 4. That's why I said the negative number has to be stronger, because the sum is negative. So then the factored form of this trinomial is, notice that negative 5 times 4 is this, and negative 5 plus 4 is this. Both conditions must be fulfilled. Otherwise, the product will not be this. So what do I have? X minus 5 and x plus 4. Good. Okay. 5mn plus m squared minus 150n squared. So normally if we have a and b, unless we are specified which one is the variable, If we have A and B, we rearrange it in descending order based on powers of A. If we have Mn, we rearrange it in terms of descending order of the powers of M. If we have X and Y, we normally start with X and then Y. Okay, so in this case, I will rearrange it as m squared plus 5mn minus 150n squared. And then I'm looking for two numbers whose product is and whose sum is. So what is the product? Yes, I normally start with the product and the sum is? Yes, I normally start with the product because the product gives me an indication of the signs. Because it's negative, I know for sure one is positive and one is negative. And since the sum is positive, the stronger number is positive. So I need a positive number and a negative number whose product will be negative 150 and whose sum will be 5. And the positive number has to be stronger. By stronger, I mean actually bigger in absolute value. That's what I really mean. 15 and negative 10. Let's check. 15 times negative 10, correct. 15 minus 10, correct. So then I have the complete factored form. We've been doing this all along from the first day of classes. But I decided that this is so important that it's worth going through this chapter again. So the answer is? Very good. M minus 15n times m plus 10n. Excellent. Okay, finally the last one here, and then we move on to the last possibility. We have x squared plus 13x plus 36. Okay, so trinomial descending order, greatest common factor, no. Negative leading coefficient, no. Special product, yes. Special product, x squared and 36. What do I conclude? Excellent. But what is the middle coefficient here? What is the middle coefficient here? Do I have 12x here? No. But this is the correct step. Check the special product first. It doesn't work? Okay. But always check first. So, okay, so in that case, I need two numbers whose product is and whose sum is. Product 36 and sum 13. Always start with the product, I recommend, because the product has more information, gives us more information about these numbers. Product is positive, so definitely both have to have the same sign. Since their sum is positive, they can be negative. So both have to be positive. Can I find two numbers whose product is 36 and whose sum is 13? 9 and 4. So therefore the factored form is? That's it. And we are finally down to all this. I know we covered this. You may want to not do all of them, but if you say let's do all of them, we'll do all of them. So therefore, with the leading coefficient not being 1. I remember I think we did all 4. But that's okay if you want to review this. So we pick and choose, or we work on all 4? All of them. Okay, very good. So let's do that. So in this particular case, we have 6y squared minus y minus 1. So we are, let me show you again where we are. So factoring trinomials, we went through all this, then special products, and when special products are not applicable, then, and the leading coefficient is 1, that was a straightforward situation. But if special products are not applicable and the leading coefficient is not 1, then we are down to this last possibility, last chance. Okay, what do we do with that? Okay, so this time, because the leading coefficient is not 1, we have to incorporate it in the product. So just the product, the sum doesn't change. The sum is still what? That's it. The sum does not change, but the product has to incorporate the leading coefficient now. So the product would be 6 times -1, which is -6. Okay. The product is -6. Therefore, the two numbers have to have opposite signs, one positive and one negative. And the stronger number will be negative because the sum is negative. So can I find two numbers, one positive and one negative, whose sum is -1? And the answer is yes. And those numbers are -3 and 2. I cannot use these numbers to factor. I will have an intermediate step. Why I cannot use them to factor? If I write x plus 2 and y plus 2 and y minus 3, that will not be correct, because I have this leading coefficient which is not 1. So what I have to do now is, using these numbers, I'm going to replace the middle term using them. So I have 6y squared, but now I have positive 2y minus 3y and minus 1. I have not changed the problem. This is still -y. But I changed the 3 terms into 4 terms now. And the method we apply for 4 terms is factoring by grouping. Factoring by grouping. So let's look at the first 2 terms. If you only had this binomial, 2 terms, to factor, what will you factor out? What will you left in parentheses? What do you have left in parentheses?
3y plus 1.
Right. Remember, if I can get a 3y plus 1 from the other 2, I'm stuck. I know I can get it. How do I know I can get it? Simply because I was able to find those 2 numbers whose product is -6 and whose sum is -1. Otherwise, there is no guarantee that this is factorable. But I found those numbers. So I know 3y plus 1 has to be in the second pair. Now I need 2 things. I need a sign. Without a sign, I mess up the whole thing. I need a sign, and I need a factor. Sign, factor. Sign means positive or negative. Factor, something that comes out from the other 2. Indeed, -1. Now I pull out the common factor. What is the common factor now? Indeed, 3y plus 1 and 2y minus 1. Let's say you don't trust this. That's okay. Here's how we check. 3y times 2y is 6y squared. -3y plus 2y is -y. And 1 times -1 is -1. Any questions on this? 2x squared plus x plus 1. Okay, so trinomial descending order, yes. Greatest common factor, no. Special product, no, because 2x squared is not a perfect square. 1 is a leading coefficient, no. So this is the last chance in which I'm looking to determine, to find 2 numbers whose sum is 1, but whose product is 2 indeed. Since the product is a positive number, both numbers have to have the same sign. Since their sum is 1, they must be positive. Can I find 2 integers? whose product is 2 and whose sum is 1, both positive? No. So what do I conclude about this? Thank you very much. Indeed, I couldn't find those numbers. They don't exist. Therefore, this is not factorable. Okay, 2 more here. 4x squared minus 4x minus 15. So, it's a trinomial. It's in descending order. No greatest common factor. No negative leading coefficient. Special product? No. Negative 15 is not a perfect square. Next step, no. 1 is not the leading coefficient. So, I have to use the long procedure in which I find 2 numbers that I use to change the trinomial into a polynomial, and then I'll see what happens. But I cannot use them to factor. These are not the numbers that will help us end factoring for this. So what do I have? What is the product? Very good. Indeed, the product is negative 60. And the sum is not changed into negative 4. I start with the product. Since the product is negative, one number must be positive and the other number must be negative. Since the sum is negative, the stronger number must be negative. Be very careful, because if you reverse them, you will not get what you're supposed to. So what do I get? The sum is this, the product is this. These are the numbers I need. But I cannot use them to factor. They are just an intermediate step. So this is 4x squared minus 10x plus 6x and minus 15. From the first 2, what do I factor out? Very good. In parentheses. What should I have coming out from the other 2? I'd rather write it first because I may mess it up. So that's why I want to put it there, safe. I put it in and then I look. Now I look. I need a sign. If you omit the sign, the whole thing collapses. So I have to have a sign and I have to have a factor. Indeed, plus 3. 3 times 2x is 6x. 3 times negative 5 is negative 15. Excellent. So then what is the final factor form? Now I have it. As you see, I'm not using negative 10 and 6 in the final answer. I use negative 10 and 6 only if the leading coefficient is 1. So what is the final?
2x minus 5, and 2x plus 3.
That's it. Careful on that. Last one here, 5x squared minus 26x plus 5. Any questions? Trinomial, descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, no. They're not. The first and last are not perfect squared. 1 is the leading coefficient. No, bless you. No. So, product is sum is product says both the same sign. Sum is negative. Then I know for sure. I need 2 numbers, 2 negative numbers whose product, 2 integers, negative integers whose product is 25 and whose sum is negative 26. Very good. Remember, these are not the numbers that will come up at the end. These are the numbers that allow me to break this into 2 terms. And do not go back and combine them, right? Don't be tempted to go back and combine them, because then you're not going to factor. So then combine like terms. Minus 25x minus x plus 5. From the first two. You do not have to write them in the same order I did. You'll still get the same answer. You can write negative x minus 25x. I wrote negative 25x minus x. It doesn't matter. We will both get the same answer. So from the first two, what comes out? What is left in parentheses? What should I get from the other two? Of course. Write it first, because you may mess it up. And then? Good. So then x minus 5 is the common factor, and what is left?
5x minus 1.
And that's it. And that's final for the strategy for trinomials. There is nothing else. Yes, the numbers can get huge. So if this is, I don't know, 180 and this is negative 55, it's not going to be that easy. Okay, last step here before we look at applications. Strategy for polynomials. Factoring polynomials. 1, 2, 3, and 4 are the same. Only 5 is factoring by grouping, with what we just did. Nothing really. Factoring by grouping. Good. So let's look at the top one. 2x squared minus 4x plus 6x cubed and minus 24x to the 5th. So factoring polynomials, the first 4 are identical. Number 5, factoring by grouping. So I see 4 terms, it's a polynomial. Is it in descending order? The answer is no. Now I have to identify the degree. So I know what to do. So what is the degree? Yes. So I know where to start. I have to start here. Negative 24 x to the 5th plus 6x to the 3rd plus 2x squared and minus 4x. Okay. Negative leading coefficient, greatest common factor. And the answer is yes for both. So I will factor out negative 2 and x. How many terms do I have to write in parentheses? Mandatory? 4. I started with 4. I have to have 4. Good. So then I have 12x to the, yes? Next, minus 3 squared. Very good. Minus x. Excellent, excellent. Plus 2, indeed. And that's it. So now let's work on these problems. We covered this one, part D. It's already here on page 1. So I'm not going to do it again, unless you want to. Okay? Also, I want to, since we finished, yes? Yes, which one? This? From before? This one? Oh. I want you to look at the last page of this handout for a second. And this is a summary of everything that we just discussed. Factoring a polynomial. Descending order. Factor out the greatest common factor. Factor out the negative leading coefficient. And then the strategy for each and every one of them. So the strategy for binomials, you only have 4 special products and you're done. The strategy for trinomials is much longer and different. So you have the special products, and then 1 as the leading coefficient, and then not 1 as the leading coefficient. And the last one, again, from the beginning, it could be a polynomial, and all you do is factoring by grouping. So this is a summary of everything we discussed. You start with the same questions, and then separate among the 3 based on what they are. Binomial, 4 special products, we are done. Trinomial, 2 special products, but you have 2 other options. No special product, no special product, 1 leading coefficient, 1 not leading coefficient. And the last option is polynomial, factoring by grouping. Okay? So if you remember this scheme that or chart, then you will remember factoring. Okay? Any questions? Okay, so let's look at x cubed plus x squared plus 2x plus 2. Descending order, greatest polynomial, descending order, greatest common factor, no, negative leading coefficient, no, factoring by grouping. From the first 2, what would you factor out? Good, x squared. What is left in parentheses? That's it. What should I have from the other 2? Otherwise, I can't continue. And now I want to draw your attention to something very important. When I have 4 terms, and I group the first 2 and I group the last 2, and it doesn't work, it doesn't mean that the polynomial is not factorable. I have to check 2 more different possibilities. So I grouped the first 2 and the last 2, and I didn't get where I was going. Well, then I have to group the first with the third, and the second with the fourth. And maybe that route is useful or helpful. There is a third option. The first and the last will be factored together, and the middle 2 will be separate. So you cannot assume that if you group the first 2 and the last 2 and it doesn't work, that's it, it's not factorable. You have to check the other 2 possibilities. Factoring between the first and the third, and second and the fourth, or between first and last and the middle 2. Okay, so there are 3 possibilities of factoring. Okay, so now I should have x plus 1. Of course, I cannot fabricate it. Now I look. I need a sign and a factor. And it happens that is plus 2. And now the common factor is x plus 1, and it's x squared plus 2. Okay. 2x cubed minus 6x squared. Oh, I jumped. I'm sorry. Plus x minus 2. I'll come back to b. I didn't mean to skip it. I just copied the third one. Okay, let's work on this for a second. And I'll put my attendance here. And don't wait for me to work on B and E. You cannot work on E just yet. I have to show you something. I'm always logged out, no matter what I do. Okay, done. Okay, so from the first two, you factor out 2x squared, and you got x minus. Did I copy it incorrectly? Of course I did. Okay, sorry about that. And plus x minus 3, so we got x minus 3 and 2x squared plus 1. Is this okay? We agree? Everyone? Okay, and back to b. So we have x cubed plus 2x squared minus x minus 2. Did you already work on b? Yes? Okay. So we have x squared and x plus 2 minus x plus 2. So you got x plus 2 and x squared minus 1. However, x squared minus 1, we know now, as we knew from the beginning of the class in August, that x squared minus 1 is further factorable. And how do I factor this? X plus 1 and x minus 1. Now I have to talk about the last one. A few minutes ago I said, okay, if you are given 4 terms, you should try 3 different options. Well, there is also a 4th one. So what are the 3 options? If you factor out here, you'll get a plus 6. There is no a plus 6 coming from here. If you factor between these two, you will have a plus b, a plus y, a minus y, but there is nothing you can come up with this. If you try here, this is not even factorable. A squared plus 9 is the sum of squares, so you can't. So here's the 4th option. It's rare. It's not common, but it's possible. What do I replace this by? We had this a few minutes ago in trinomials. What do I replace this by? Very good. A plus 3 everything squared. Now I copy minus y squared. Now I'm going to cover these. And since it's difference of what? How do I factor the difference of squares? What I have under my left finger minus what I have under my right finger times what I have under my left finger plus what I have under my right, right? It's a squared minus b squared, right? So I have a plus b, a minus b, correct? One more time, this is a difference of squares, correct? It's difference of squares, right? So this minus this times this plus this. Okay. So can anyone give us that? What we just said? One more time. This minus this, and this plus this. Ready? Give it a shot. A plus 3 Okay, doesn't matter, plus y. And the other one?
A plus 3 minus 1.
Exactly. So again, this is rare, but it happens. Not as much as the rest. Okay, now for the rest of the class, we have half an hour. We're going to look at the first application. We've done all this, but less at higher degree. This we haven't. So I would like to first factor. I should have changed the order here. I would like to factor these and then work on equations. Okay? Because then we have equations on the back. And that will be the end of chapter 6. So first I would like to jump here. Factoring higher degree polynomials. Everything we looked at was degree 2. So now I would like to look at other polynomials that have other degree or higher degree, except one. I think we had, yes, degree 2 and 3, and we also had 4 here. Yeah, we had degree 4 here, degree 3 here. Yes. Okay, so let's take a look. So 6x to the third minus 26x squared minus 20x. That's where the strategy is absolutely crucial, because now you're going to say it's a trinomial, which is indeed, but it's degree 3. It's in descending order, yes. But if I don't factor out the greatest common factor, I may never be able to factor. So one more time. It's a trinomial. It's in descending order. Greatest common factor, yes. Negative leading coefficient, no. So what will I have to pull out from all three? From all three. What? 2x. Okay, what is left in parentheses? How many terms, first of all? Yes. So then I have 3x squared minus 13x and minus 10. Now I'll say, okay, special product, no. 1 is the leading coefficient, no. I'm down to the last option, in which I multiply 3 by negative 10 to get negative 30 and a sum of negative 13. So see, these are already more involving situations, because now I have degree 3. Now I have more than 2 factors, and one of them is already in front. If you want, 2 is 1, x is another. And now I have 3x squared minus 13x minus 10, which is where I was before. So the product is negative 30. It tells me that I'm looking for a positive and a negative. And the sum is negative 13, which tells me the negative 1 is bigger and stronger. So a negative and a positive. Yes. 2 and negative 15. Let's check. Negative 15 times 2, yes, is negative 30. Negative 15 plus 2, yes, is negative 13. These are not the numbers I will be using to factor. These are just the numbers that will help me break down the middle term. So I have 3x squared minus 15x plus 2x and minus 10. So 2x is outside, still there. Nobody can touch that. And now, from the first two, I will factor out 3x. And then I get x minus 5. What do I have to have coming out of the other two? Otherwise, I can't continue. And I know they're there. It has to be x minus 5. Now I need a sign and a factor. So it's going to be plus 2. And you see it's there. We didn't fabricate it. 2x minus 10. And now finally, the factored form of this is 2x, x minus 5, and 3x plus 2. Exactly. Way more work than what we had before. 3x to the fourth minus 8x squared plus 5. This is even more work than the previous one. Not because the degree is 4. Not because of that. It's because in order to factor this, I should use a substitution. You don't have to. I recommend it though. Substitute. Now the question is, that I'm sure you have it on your minds, is how do I know? Why didn't I substitute here? And how do you come up with this all of a sudden that I have to substitute? Well, here's how I came up with it. I see that this is degree 4, and I see that this equation is, although it has degree 4, is quadratic in form. What is that? It means that it can be replaced by a quadratic equation if I want to. And I do want to, because it will be easier, a quadratic expression. Yes, and I do. It's not an equation. It's a quadratic in form, polynomial, quadratic in form. Yes, I can replace this polynomial by a quadratic polynomial. So the question is why? Because it's easier to factor. So I'm going to say, let t, let's say, be x squared. And how do I pick this and not something else? You can pick any letter here. But how do I pick this to substitute x squared? Because I noticed that if I denote this by t, this is clearly what?
T squared.
Right. Exactly. So I change this into 3t squared minus 8t plus 5, which is easier to factor. And you can say now, but wait a minute. Your expression, the expression was given in x. You all of a sudden come up with t. True, but in the end I'll go back. And the answer will still be in x. And you'll see how in a minute. So I know it's quadratic in form only because if I replace this by a letter, this will be that letter squared. What if I have, don't change anything. What if I have this? This expression is not quadratic in form because there is no connection that I can use or have between 2 and 3. But the connection between power 2 and power 4 is there. If this is t, then this is t squared. But if this is t, I can't get a t. I cannot express x to the third in terms of t. So that will not be quadratic in form. Okay. So now this is a polynomial that I've been dealing with. It's in descending order. It's a trinomial descending order. Greatest common factor, no. Negative leading coefficient, no. Special product, no. 1 is a leading coefficient, no. So my only chance is to find two numbers whose product is and whose sum is. The product is and the sum is. Right. Since the product is positive, both numbers have to have the same sign. Since their sum is negative, they must be negative. So can I find two negative numbers whose product is 15 and the same number's sum is negative 8? Very good. Both are fulfilled. So then I continue. 3t squared minus 3t minus 5t plus 5. As you see, we did not change the problem. Negative 8t is still there. But now I factor by grouping. From the first two, I factor out 3t, and I have t minus 1. I have to get a t minus 1 from the other two. Now I look, and I have negative 5. So then, in order to finish this, I will write t minus 1 and 3t minus 5. And now, I'm going to go back to my substitution. What was t? What did we denote by t?
X squared.
Right, that's all I have to do. And please tell me the final form. Good. However, one of them I learned today that I can factor. And how do I factor that? This is a very useful method, especially if you need to go to pre-calculus. This will be an extremely important method. The method of substitution only when the expression is quadratic in form. This one was not quadratic in form. There was no way I could do anything here. But this one is quadratic in form. In other words, it can be replaced by a quadratic expression, which I know how to factor. So only for expressions quadratic in form. Okay, 4x to the fourth minus 64. Okay. It's a binomial. It has degree 4, but it's a binomial. Is it in descending order? Yes. Negative leading coefficient? No. Common factor? Yes. There is a common factor that will be pulled out from both, which is 4. 4. So I have x to the fourth minus. Perfect. Now I look at x to the fourth minus 16. I'm debating with myself, okay, special product, either the difference of squares or the difference of cubes. Cubes have nothing to do with x to the fourth, or 16 for that matter. So now if this is factorable, I will definitely think of the difference of squares. So then this will give us excellent. Which of these two I can do anything to? Correct, that's the sum of squares, but I have to continue factoring x squared minus 4. So x squared minus 4 will be factored into, very good. Okay, one more here and then we look at equations. There are so many different types. Okay, 6x to the fifth minus 47x to the fourth plus 35x cubed. This is not a friendly expression at all. At all. It has degree 6, but that's not degree 5, but that's not the problem. The problem is that the numbers are big. 6, 47, and 35 have nothing in common. The only thing I can factor out is x cubed. But then I'm looking at a difficult situation. Why is this difficult? Because I have the product, which is 6 times 35. I don't even recommend you multiply it. Just write it as 6 times 35. I'll explain in a moment why. And the sum, which is negative 47. Don't bother to multiply that, because it's so big that I can't figure out what I'm looking for. I'll show you how to do this. Okay, so let's establish the signs first. So we have a product of two numbers, which is positive. Both numbers have to have the same sign. But since their sum is negative, both have to be negative. We have to establish that from the beginning. Okay, so here's what I do next with this. I take it aside, and I change it into prime numbers. Prime numbers. It's called prime factorization. 6 is 2 times 3. 35 is 5 times 7. And now I stand here and look at these two numbers and try to get, using all four, come up with two numbers whose sum is 47. Using all four factors, come up with two numbers only whose sum is 47. So let's think. If I have 35 plus 6, that doesn't work. If I use 10 and 21, that will be 31. It doesn't work. If I use 14 and what is this? 15. 14 and 15 is not 47. So what else can I do? 10 and 7, that will be 70 and 3. That's not going to work. Let's see if I multiply these. So that's 30 and 7. That's not going to work. Is there anything else I could do? Yes. Yes. You said 5 and 7?
3, 5, and 7.
3, 5, and 7. So this is 15 times 7. I'm way over that. Here's my last chance. And this one alone. And that's what I need, the 42 and the 5. 2 times 3 is 6. 6 times 7 is 42, and then 5. And that's all I need. So it would be more difficult if you multiply this and try to figure it out. But always, if the numbers are so big, this number, 6 times 35, it's so big, always come back to prime numbers. This will always be easier. Well, when we get to chapter 9, where I'm still saying 9. When we get to chapter 11, which is the next step after this chapter, after we review this, we're going to look at the quadratic formula and we can use that. But right now we don't have it. Okay, so I'm back to finishing up this. So I have x cubed outside. I have 6x squared. I have minus 42x, I have minus 5x, and I have positive 35. I know it's factorable because I found the numbers. I found two numbers whose product is this and whose sum is this. So then I have x cubed outside, and then 6x, and then x minus 7. I have to get an x minus 7. Now I look. It must be minus 5. So I have x cubed, x minus 7, 6x minus 5. Not a friendly situation. Not an easy to deal with polynomial at all. At all. I know we have 10 more minutes. Let's just do a couple of equations. This is why we learn how to factor. One of them. Okay, so let me refresh your memory. If I have a product of, let's say, 3 factors, set equal to 0. They're all factors because they are multiplied. What can happen here? In how many ways can I get 0 if I multiply 3 factors? Bless you. I can get a 0 if A is 0. I can get a 0 if B is 0. Or I can get a 0 if
C is 0.
correct. This is what it's called, the zero product principle. The zero product principle. So let A and B be 2 factors or 2 real numbers. The equation A, B equals 0 is true if and only if A is 0 or B is 0. That's how we get 2 options. If we have 2 factors, we have 2 options. If we have 3 factors, we have 3 options, and so on and so forth. So looking at x minus 2 times 7 minus 4x is 0. I have 2 factors. This is factor A, and this is factor B. Either one can be 0. If x minus 2 is 0, or if 7 minus 4x is 0. Say it again. I put exactly what you told me. Either A is 0 or B is 0. Exactly what you just said. Good. So if x minus 2 is 0, then I have x equals, we've done this from the first day of classes, x equals 2. And here I have to move 7 first. Negative 4x equals negative 7, so x equals 7/4. These are our two options. Now, of course, this was already factored. I didn't have to factor. But here I have x squared equals 100. You can say, I don't want to factor this one. And I will have to agree with you because we learned a different method in chapter 10, in which we did what? Exactly. So then x equals, and if I miss something important on the right-hand side, then I mess up the problem. What am I looking for here? Exactly. And I'm done. However, let's also look at it as if we don't know how to take square roots. Well, I have to move 100 to the other side, and I have to factor this. It's a binomial, it's in descending order, greatest common factor, no negative leading coefficient, no special product. Yes, I always hope for a special product. And what is the special product here? Yes, x minus 10 times x plus 10. That's how I get x equals 10 from here and x equals negative 10 from here. Exactly as we got with taking square roots. Any questions? Any questions? Okay, 4x squared minus 18x equals 70. So now we've known this for 2 months. What type of equation is this? What do I have to do with the quadratic equation? Set it equal to 0. So I have 4x squared minus 18x minus 70 equals 0. Now, because it is an equation, when I get to the step in which I say, okay, it's a trinomial, it's in descending order, yes, greatest common factor. As long as I don't factor out a variable, I can simplify. I don't have to keep that 2 in the equation because 2 will not give me an extra solution. So I simplify, and this is 2x squared minus 9x minus 35 equals 0 over 2, which is 0. This is because it's an equation. Before, when we factored, I could not drop anything. See, I had a 2x here. I had to carry it all over the place. But here, it's an equation. Dividing both sides by 2 will not change the solutions. Okay, so now I'm back to no special product. No, 1 is not the leading coefficient. I'm back to my routine. The product is negative 70. See, this would have been way more difficult with negative 280. So that's why the greatest common factor is crucial. But if you have an x in front, you cannot divide by x, right? But by 2, it's safe. It's okay. So this is negative 9. So I need to find 2 numbers, one positive and one negative, because the product is negative, whose product is negative 70 and whose sum is negative 9. You could say negative 70, that's a big number, and I would have to agree. So instead of 70, I'm going to say 7 times 10, or 10 times 7, 2 times 5 times 7. And this will be much easier to come up using the prime factorization of 70. It will be much easier to come up with 2 numbers, one which is negative, much bigger, stronger, and then the other one, and to get negative 9. Look at the possibilities of 2, 5, and 7. And there is only one that will click in a minute. Say it again? 7, no, I have to use all factors. It has to be 70. I have to use all of them. And come up with 2 numbers. One is positive and one negative, and when I add them, I get negative 9.
14 and 5.
Exactly, negative 14 and 5. So negative 14 and 5. You have to use all of them because the product is still negative 70. Very good. So thank you. And now I change this into 2x squared plus 5x minus 14x and minus 35 equals 0. And I'm back in the same situation. Have to factor by grouping. I will factor out x from the first two. Do not change the order. If you put a different order, continue with your order, because we'll get the same answer. And 2x plus 5. And now I look, and I get a negative 7. So then 2x plus 5 and x minus 7 equals 0. And then I get two options. And the options are negative 5 halves, as we had so many times, and x equals 7. So I'll stop here. I just want to say one more thing. So on Tuesday, we will complete these, and we will complete these, and then we will start chapter 9. Okay, so these are, of course, a little bit more difficult because the degree is higher, like we just had with all different situations with